Okay, so today we are doing lesson number 3 on page 515, which is solving linear inequalities in two variables without technology. So it's a really long title, but basically what it means is that we're working with linear functions, so those are ones that are just straight lines, with two variables, so they're going to have an x and a y, and without technology, which means we're doing it algebraically. But I'll show you how to check your work using a calculator. So everyone should get 100% on tomorrow's quiz. Okay, so first things first is just as a bit of review with these symbols here. When we're graphing them, if it's just a greater than or less than, we graph them with a dotted line like that. And if it's greater than and equal to or less than and equal to, we do it with a solid line. Okay? So if they give us the equation, or I guess the inequality, it's not too big of a deal, but it becomes a big deal when all they do is give us a picture and they say, what's the inequality? So we have to look to see whether they have dotted lines or solid lines. If we're working with number lines, if it's not including the equal to, we do an empty circle like this. And if it does include the equal to, like greater than and equal to, or less than and equal to, we do a filled in circle. Okay? So, as a bit of review, we're going to do a problem that just has one variable in it. So it's just going to have x. So just a quick recap on how to solve these. So we have 4 minus 2 multiplied by 3 plus x. It's greater than 12. And so we start off by solving these just like we would any other algebra problem. We go and get rid of our brackets. We'll have 4 minus 6 minus 2x. It's greater than 12. We can gather our like terms. So we get negative 2 minus 2x. It's greater than 12. And we want to get our x on one side and all of our other numbers on the other. So get negative 2x greater than 14. And then we want to divide by negative 2. So what happens when we divide by a negative number? Awesome. Okay, so we get x is less than negative 7. Okay. So how we got this should make sense to everyone because this is the kind of stuff we've been doing for a good part of this year so far. And then they ask us to check the solution using a test case. So when we choose a test case, kind of like in the last unit, we just want to choose something that fits with this. So we need a test number that's less than negative 7. Yeah. See, just like in the last unit, we want to make it as simple on us as possible. So you could choose a number like negative 7.65932, or you could choose a number like negative 10. So in your notes, you can choose one, but in my notes, I'm going to do negative 10. I say test point, x is equal to negative 10, and I'm going to say negative 10 is less than negative 7. Okay? And then so when you're doing this, all you have to do is substitute the negative 10 back into the original. So we go 4 minus 2, 3 plus negative 10 is greater than 12. So we get 4 minus 2, 3 minus 10, so we get 6, that, 4 plus 12, greater than 12, and we get, oh, what? Oh, dang, that was it. Good catch, guys. So we get 18, so we get that, oh, 18 is greater than 12. So we say, fantastic, this is true. Okay. And then so we can say, okay, when they ask us to graph it on a number line, here's our line for x. Here's our point -7. And we know that because it's just less than -7 and not necessarily less than and equal to -7, we go like that. Okay? So if you find that you choose something in your interval and then it results to be false, you should be checking your math in here and in here. Okay? So if you choose something that's in your proper interval, you should always get that it's true. No, we only want to use this dotted line when we are graphing it like on a grid like that. Yeah. On a number line, we show it by using the empty circle. Good question, though. Okay, so if we flip the page, so now they're talking about two variables. So like I said, that's just x and y. So it's nothing too like scary because we've been working with x and y all along. So they have all these steps for graphing a linear inequality. So as the side notes, the first step just states draw the line. So if they give you an equation or an inequality, just draw that. And then obey boundary rules. So that just means if they have the inequality as less than or greater than, make sure you use a dotted line. If they have it as a less than or greater than and equal, make sure you use a solid line. Okay? The second step is to find a test point. And you want to choose one that's not on the line. Okay? Okay, so once you find it, you can test it. So find a test point not on the line, and then test it. Okay? And then for number 3, they want you to shade the correct region. Shade, like color. Okay, so we go down to example 2b. So just like in today's quiz, the first thing we want to do is put this in the form where we have our y isolated, because that's how we put everything in our calculators. That's how we see everything when we have our equations in their normal form. So it's always just a good idea to get it into that form with y isolated. So we can subtract 3x from both sides. Negative 2y is less than or equal to negative 6 minus 3x. We're going to divide by negative 2. So what does that mean for everything else? And what else? Awesome. So our sign's going to flip. We're going to get 3 and 3 over 2x. Okay, so y exactly, not a robot. So we know that y is greater than or equal to 3 plus 3 over 2x. Okay, so the next thing we should do is we should actually graph our line. So I would graph this. There's a couple different ways you can do this. You can find your x and y intercept and then draw a line through those points. Another thing I do often is I'll just graph that line by itself on the calculator. find that x-intercept and that y-intercept, and then you can very nicely draw it through 2 points. Okay? So you want to try and get it like as exact as you can, because if you just kind of like be like, oh, it looks like that, and then you're finding a test point, you don't want to use a test point that actually isn't in the region you think it is. Okay? So, pull up the calculator like that. Okay, so 3 plus 3 divided by 2x. So I would hope you would use the calculator to check your math and stuff. Okay? And I say, okay, well, our x-intercept is at -2 and our y-intercept is at 3. So I know when I draw the line, it's going to be just like we've been doing all year. Okay, so you can go second trace value. Our y-intercept is 3. Our x-intercept is -2. Intercept. Yeah. And then I have my y2 equal to 0. Okay, so our line will look something like that. And because it's y is greater than and equals 2, we know that it's going to be a nice solid line. Okay? So once we have this line drawn, all we have to do is choose a test point that's on one side of the line or the other. Okay, so it can't be on the line, but it doesn't matter which side we choose, the coordinate, as long as it's not on that line. It'll work. I can think of, like, what's the easiest one you could think of using? Yeah, exactly. So personally, I like to use the origin because that's something where you can usually tell pretty quickly whether or not your graph goes through that. And it's the easiest one to work with. Most of the time, it just sets everything to equal 0. Okay, so we can go, okay, test point of 0 and 0. And then so you can put it back into either one of these equations, this one or this one. I'm going to go 3, 0 minus 2, 0 is less than or equal to -6. And we find that, okay, 3, so that's 0, minus 0 is less than or equal to -6. And say, oh, well, 0 is not less than -6. Not true. So what this means is that this portion here, this, it's called a half plane, is not our solution set. Okay? The other half is. Okay? So wherever you choose your test point, if you find that it's true, that's where your solution is. If you find that it's false, it's going to be the opposite. Okay? Exactly. So shade it up here. So that you can show me on a test where that solution is. Yeah. Okay. So we know that, like I said earlier, there's lots of ways in this unit where you can check your answers. So for this one, if you have this one here, so you have to get it in that y form first before you can put it in your calculator. So I have 3 plus 3 over 2 multiplied by x. And then if you go over like this, and you go past the thick line to that, you can see it looks like a little triangle on the top. That means greater than. Okay, so if we graph it now, it'll graph our solution for us. There is another one, exactly. So that's the greater than one. So, and you can kind of make sense, like, oh, it's on top, it's greater than. If you go and click once more, you'll find, oh, here we have the bottom part colored in, which means less than, and you'll get the opposite. Okay? So on a multiple choice question, this is what I would do, right? I wouldn't be fooling around with test points and stuff like that. I'd get it right into this form with the y isolated, and I'd put it into my calculator. Okay? Yes, Aaron? There's no solution? I don't think that's really possible with greater than or equal than, or greater than or less than, because it's always going to be one or the other. Yeah, so exactly. So what this shows you the greater than or less than. There's not really any way to determine whether or not it's a greater than equal to or less than an equal to. But you find that out from looking at this and from looking at this line. Yeah. Exactly. Okay, so if we flip the page. So just like in the last 2 units, what I want you guys to do when you're doing your quizzes and your test is first thing is graph it. Okay? So find that answer and then work towards getting it. Okay? So we have 3 over 4 x plus 3. And we know that it's y is less than. So we're going to go all the way over like that. We know it looks like that now. Okay, so okay. Okay. So I have a dotted line because it's not less than and equal to, it's just less than. And we already know that this is our solution area. We look here. So I'm already going to shade it in because I know that's what I need to find. Yep. The dotted line because it's just y is less than. Yeah, then it'd be a solid line. So just a quick recap. What did I say are the 2 points you should look for to make sure you draw your line accurately? Y and x intercept. So maybe at the top here, write that as a side note. So find y and x intercept to draw line. Okay, so for your y-intercept, you have to go second trace value, and then x is equal to 0.
Line 3, when you go up 3 over 4.
Mm-hmm.
Okay.
3 over 4.
Coming up 3, go over 4, draw your point you're done.
Okay. Exactly. So, so next thing, we have our equation in the y form already. We have a line drawn. We want to find Okay, so today's homework is
Oh, it all.
1 to 9. You can omit number 10.
Yes.